Welcome to the SolarWorld cell production plant in Freiburg. This plant uses a fully automated process to manufacture multicrystalline silicon wafers. Our silicon wafers are inspected and cleaned before they enter the cell manufacturing area. Under clean room conditions, the wafers pass through additional cleaning baths, where every last bit of silicon sawdust or kerf that accumulated during the wire saw process is removed. These baths also contain a variety of chemicals that etch the surfaces of the wafers, a step that experts refer to as texturing. Zooming in on the wafer by a factor of 10,000, one can see how the surface structure changes. Countless dimple-like recesses become visible that give the future solar cells a larger surface area while minimizing unwanted light reflections. As a result, the cells can absorb more sunlight and generate more electric energy. Before this point is reached, however, our wafers must pass through a number of processing steps, the most important of which is probably a phosphorus diffusion step. In pairs of cells, placed back to back with one another, the wafers enter a tube furnace, where they are heated to over 800 degrees Celsius and diffused with phosphorus gas. This gas condenses on the open surfaces of the wafers. It penetrates the wafer and forms two layers with differing electronic characteristics based on their respective atomic structures. The base material is silicon, which previously was mixed with boron atoms during crystallization. Boron is used because it has 3 outer electrons, one less than silicon. A positively charged hole is thus created in the atomic bond. Diffused phosphorus atoms are slightly different. They have 5 outer electrons, which means one more negatively charged electron than silicon. The result? 2 different charge carriers, negative electrons and positive holes, that strive to achieve an equipotential bond according to the principle of opposites attract. The free charge carriers really get going when the sun's rays hit them. In sunlight, the photon's light energy virtually shoots large numbers of charge carriers from their bonds. This effect generates an electric field between a positively charged layer and a negatively charged layer. The charge carriers try to escape from this field, thereby causing the difference in potential to increase even further. If contacts are applied, the charge carriers will take the path of least resistance, which in turn generates a flow of electrons or electrical current, illustrating the photovoltaic principle. It takes approximately an hour to convert positively doped wafers into conductive wafers. The result is an electric component that transforms light into electricity. However, before you can actually take advantage of this effect, further production steps are necessary. Once again, the cells are cleaned and etched under the scrupulous supervision of our staff. The 0.2 mm thin cells are then placed in an acid bath, where only their bottom and edges are exposed to the acid. The effect, the positive side, the bottom, is electrically isolated from the negative side, the top. The solar cells then enter a plasma chamber, where they are given their typical color. The blue surface reduces optical loss by preventing unwanted reflections. As a result, more light can enter the cells, and more power can come out of the cells. However, to actually conduct electrical power from the cells, metal contacts are needed. Screen printing machines are used to apply a contact area with solder strips onto the backside and thin contact fingers onto the front side. High-performance furnaces then burn the contacts into the silicon. The solar cell is now permanently bonded with its current collectors. A conductive solar cell has been generated from a silicon wafer. Sensors check the cells once again for possible fractures, cracks, or other imperfections. Other measuring processes check the cells for their performance and other electrical properties. The best-known parameter in this regard is efficiency. Efficiency refers to how much electrical power a cell can generate when it is exposed to 1000 watts of artificial sunlight. Depending on the test results, classifiers sort the cells into 32 possible quality grades. Indispensable, the final quality assurance check. So far, machines have tested all parameters, but now our experienced staff is on hand to monitor the products. The solar cells do not receive the seal of approval from our experts unless they meet our strict quality standards. This is how Deutsche Cell in Freiburg manufactures around 1 megawatt of solar cells every day, enough solar cells to power 250 homes. Solar cell production can hardly be any faster or more energy and cost efficient. This is what we at SolarWorld stand for. We turn sunlight into power.